to start off with, this first one has a common denominator, or each one does, because what we want to do in here is when we have addition or subtraction, we want to look at these parts as being grouped together. So are the denominators the same on both of these expressions, both of these fractions?
Yeah.
Yes. So to then subtract or to add, we just work across. 4 and 6ax are not like terms, so we're just going to write it as 4, and then the sign between them, minus 6ax, all over 2x squared plus y. That is your answer for that one.
Really?
For that one. Don't get too excited that they'll all be that nice and neat and easy.
Because they're not.
They will get more complicated. Do they each have a common denominator in this problem? Yes. So I have a 5 minus 3 plus z, so I do have a couple of like terms in my 5 and my 3. So 5 minus 3 is 2. And then the z is by itself. And then I'm just going to put it over the a squared plus 7y. So you do want to combine those like terms at that point if you can. Another one here that has like terms, and then it also has a batch of stuff in the numerators that we need to work through. So what I want you to do when you see this plus and minus sign on the numerator or the denominator, I want you to group those in parentheses. Because if you do add or you do subtract any of those parts, you have to do the whole thing. Now, we have a common denominator, so I can just show this as 5x plus 7 minus 3x minus 2 all over 5a squared x.
What happens if you don't put it in parentheses?
Can we drop the parentheses on this first one?
No.
What's the sign in front? It's just plus, so I can go 5x plus 7. What does the negative in front of a set of parentheses tell us to do?
Change the sign.
Change the sign, so my positive 3x inside becomes negative 3x, and my minus 2 becomes plus 2 over 5a squared x. And then add your like terms. 5x minus 3x is 2x. Plus 7 plus 2 is 9 over 5a squared x. Now, Kelly, let me go back to your question. Kelly said, do we have to put the parentheses? If we didn't put the parentheses around this term here, but we had the minus sign in front of it. We brought the minus sign down, and then we just wrote it without parentheses. This is not the same thing here as what we end up with here, is it? Because here you're just showing to subtract the 3x, but the problem is telling us subtract this entire piece.
So did you like distribute?
Yes.
the sign?
Yes, and that's why we changed the sign of each one of those. Kelsey.
So could you, like with the x on 2x, take the x from below and like cross it out so it's 2 plus 9?
Good question, but no.
Why?
She's asking, can we cancel on this? Can I take the x right here and cancel it with the x right there? I want you to tell me why not. Can you see why not now that I said no, that you're not supposed to? Want some help? Cole.
Because there's a plus sign in the numerator.
Yeah.
Okay.
Yeah. This is being added. I know it looks kind of like a time sign.
So if it wasn't being added, you could?
If it was being multiplied or divided, then we could reduce it. But it's being added. Remember, division is not the opposite operation of addition, so we cannot divide a part out of an addition sequence. And that's another reason to get this in parentheses maybe, because you can't just take out the x out of this parenthesis and reduce it there. You'd have to take an x out of each term and then have it
So
reduced.
instead of a plus sign, you have a multiplication sign, then you could just go ahead and...
Yeah. Okay. these two fractions do not have a common denominator. What would the least common multiple be for 4b?
B.
4b. Okay. You could almost do the old Trojan swing. Did you learn the Trojan swing last year? Swing from the left, swing from the right, multiply the denominators, fight, that type of thing. We're not going to do that though. The common denominator though is the product of these two because that's the least common multiple. So we can write this as 4b and 4b. What do I do to 4 to make it 4b?
Multiply it by B.
Multiply it by b, and if we do that to the bottom, you have to do it to the top because that is what we call a well-chosen one. B over B. I like it. B over B is a well-chosen one, and multiplying by 1 does not change the answer, does it? So 3 times B on top would be 3B. We multiply the B by 4. Multiply the top times 4. There's our well-chosen one. That's 8. Now get them combined and just put 3b plus 8 over 4b. Kelsey, can I reduce my b's?
No.
No, I cannot. Cannot reduce my b's because of the addition in the top sequence there, the top expression. Okay?
I am very lost.
Which part lost?
How'd you get the common denominator? That's the part I want.
Kelly, if, let's hypothetically think of it this way. Let's keep our 3/4 as is. And say B equals 3. We had to plug in a 3 for B. And so you have 2 over 3. How would you get the common denominator between those two? How could you get a common denominator? It may not be the least, but you could get a common.
You take 12 and 12. Because that's what they have in common.
Because 3 times 4 would give you 12. So you can always multiply those two to get a common denominator. That's where the Trojan swing from the left. So you get 3b plus swing from the right is 8. Multiply the denominators, 4b, and then 5.
Okay, good.
So you can do it that way. It's not always the best way because you might, if you say you had 12 and 14, if you take 12 times 14, that's some number over 100.
So we can't
But their
use-
least common multiple is actually 84. So what you'd end up having to do is reduce more at the end is what it does. Okay, you can still do it, it just creates a little more work on the other side. But here, our denominators are B, C, and 2. So what's the common denominator going to be? 2BC. So we'll rewrite each of them. 2BC, 2BC, 2BC. So what do we need to multiply B by to make it look like this? 2C. That's 8C. Multiply C by 2B, 2B, or not 2B, and then 2 times BC. 1 times BC is BC.
Why didn't you times the B with the 4?
Because I already have the B on the bottom. And remember, this has to, you asked why I have to do this every time. Here's my well-chosen one. So I could, whatever I multiply the bottom by, it has to be the top. I didn't multiply the top times C because I already have a C on the bottom. Didn't multiply by 2 because I already had the 2 on the bottom. Then get those all put together over one denominator. There are no common or like terms here. So just go 8C plus 2B plus BC over 2BC. And I do want it written down.
So
there.
why? Okay, no way. I gotta see.
You'll figure out your own little shortcuts. I'm just showing you the complete way to do this. Now they're all exponent, or they're all variables,
The 4.
it's still, well, I'm sorry, the denominators are all variables. And so what's the common denominator? X, B, C, X, B, C, X, B, C. What do we need to do to make that one look like the common denominator? BC. So 5BC.
What's that be? X squared C.
That's right. X squared C. ABX or XBA, the order on that doesn't matter. And then put it all over one denominator. What's our common denominator going to be for our numerical expression, Kelly?
C5.
Let's go back over here. What was our least common multiple for our m's on this problem? Was it m to the 6? M to the 4. So it's going to be c to the third. It's actually 1c to the third, but we don't need to put a 1 with it. So c to the third, c to the third, c to the third. This one's going to stay as is, the first one is. Then we need to take our second term by a c. We need to take our last term by c cubed.
Why didn't you make the 4 top one the C3 C cubed? Wouldn't it be
Because all I had to do to change c squared to make it look like c cubed is multiplied by 1c.
So if it was a bigger number, you'd have to multiply like.
Well, on here, I needed a c cubed on this one, so I multiplied by c cubed.
Well, wouldn't it be like if it? But what I'm saying is, if it was a bigger number, you'd have to multiply by c and whatever it took to get c3.
Right.
Okay.
So 6c cubed, I left the 6 off, sorry about that. Then just write that as m plus 4c minus 6c cubed over c cubed. Can you reduce your c cubes?
Yeah. No, because it's multiplication.
No, you cannot, because you have subtraction.
I'd like
If there were like terms, you could.
Oh, so if you had a time, wait, if you had a plus sign and a times sign, could you only reduce 1?
Don't even try to figure that out. We have addition and subtraction, so we can't do it.
That's all we're doing today.
What was that? Are we doing the
Just easier. I don't want to like get to it. Not want to do it.
Couple more. Common denominator for 4, 2, and b. B.
4B?
Could we do 4b?
Oh, yeah.
Oh yeah.
You could do 8b, and again, it wouldn't create a problem. It's just going to add
Reduce.
a little bit of reducing at the end. So we need to take 4 times b. So you have pb. Take 2 times 2b.
You get 2 baby.
And then do put the coefficient first. And the order of the variables isn't a big deal. And then times 4 is 4c. And then put all that over the common denominator once. A little sloppy, but that's where you're going on it. Last one. It's going to be c to the 4th, but your numerical coefficients, you have a 3 and a 4, so that part has to be 12. So it's 12c to the 4th.
What? I thought you said we could only get that bigger one.
Right, we did. We took the bigger one.
No, I'm talking about the 4 and 3. Wait.
Last time they went into each other.
Yeah, last time we just got the 4 instead of 8.
That's because there was a 2 and a 4.
They go into each other.
Oh, because it's double each other.
Yeah. You're trying to make this something bigger than it is. Common denominator for 4 and 3 is 12. Common denominator for 4 and 2 is 4.
Oh, I remember
So what do we need to multiply c squared by? 12c squared. So that's 12ac squared. This one we just need to multiply by
3C.
3c.
9.
3c is 9c.
Minus 4.
And times a 4, 4m. And so 12ac squared plus 9c plus 4m over 12c to the 4th.
Would our answer be wrong if we didn't put it all over 12C4? If we just circled it like.
Yes.
It would.
So that you don't do it. No, it wouldn't be wrong, but I want you to clean it up.
It looks better.
If you were adding numbers, just numerical numbers, and you had 8/24 plus 7/24 minus 6/24, you're not going to leave your answer like this. You're going to work it on out. You'd work it on out, put it over one denominator.
Yeah, but you wouldn't.
Get out of here, 212.
Supposed to. So your assignment. Problem set 44, 1 through 30, due Friday with a test tomorrow. I do have your test graded other than Wade's because
You didn't finish it.
we don't know where Wade's is because we're not sure you took it.
I took it.
You took it?
Can we just have our test back and I'll show you?
That goes in the, did you look through your notes and
Oh,
stuff?
Mr.
Make sure you
Covington?
didn't stuff it back in your... Yes.
Can we go away all our lessons?
That's a good question. You may discard your trimester 1 lessons if you've seen your grade for your math class and you're good with that. All right? Anyway, test Thursday, tomorrow.
Here we go.
Yes.